Oh, we're not there. 2, 3A.
Show me your art.
Okay. We are going to be still doing if-then statement type stuff. But now there's something called a biconditional. So there's conditional, converse, inverse, contrapositive, right? The 4 things we talked about. Do you remember how those went?
I'm wearing Converse right now.
Conditional was if P then Q, right? What was the converse?
Mine are black. Mine are black too.
Hey, I don't care about your converse.
That's what we're talking about.
No, I care about this converse, not your converse. Conditional is if P then Q. Converse is if Q then P. Then we went to the inverse. Do you remember what that was?
Converse is one of the words. Can we change the word converse to something else?
No. If not P, then not Q, right? Remember we did the little dance? It went back and forth and back and forth.
That doesn't make sense.
And then the contrapositive was if not Q, then not P, right? So those were the 4 that we talked about. Now we're going to talk about what's called a biconditional. So a biconditional uses these 2, the conditional and the converse only. So if P then Q and if Q then P, put it away. What you have to do is come up with, does this setup work with a biconditional? And a biconditional is just a single true statement. If your conditional is true and your converse is true, rather than have 2 if-thens, you can take out the if-then and you put in if and only if. Have you ever heard someone say that? You can do this if and only if you do this, right? The idea is it is something that is reversible.
Sounds like something my mom would say.
Yes, totally. You don't ever have to write if and only if. If I see IFF from you, that can be your if and only if. Okay? So rather than write this whole thing, just write it like this. IFF. Okay? If you write IF, cadence. If you write IF, it is wrong. If you write IFF, I will know you mean if and only if. Okay? So just make sure only on the biconditionals you do IFF. All the rest of them, you'll use IF. Okay? So here's how a biconditional works. You will be given a statement. Okay? Typically it's an if-then statement, and they'll say, what's the converse? And therefore, because of that converse, can you write a biconditional?
Wait, there's only 3 lessons for chapter 2.
4. 2:1 through 2:4. Yeah, it's a short one. Okay, so this one says, if the sum of the measures of 2 angles is 180, then the 2 angles are supplementary. Okay, now think about that statement. If the sum of the measures of 2 angles is 180, then the 2 angles are supplementary. Is that true?
Yeah.
If 2 angles sum is 180, those angles are supplementary. So that's a true statement. Okay? Then they say, okay, now write the converse. Can anyone tell me what the converse of that statement would be?
If 2 angles are supplementary.
Good.
The opposite.
If 2 angles are supplementary,
Good job. What?
right? So we're just switching these. If 2 angles are supplementary, then their sum is 180. Okay? Now ask yourself the question, is that true? If 2 angles are supplementary, then their sum is 180. That's true. Okay, so here's how it works. If they are both true, your conditional and your converse, that's when you're allowed to write a biconditional. So what we do is we go back to that original statement. We take out the if, we take out the then, and we put in, anybody? What was the phrase I just showed you? IFF, if and only if.
Ooh.
Okay, so now we're gonna say for our biconditional, and you can do it from either one of these. You can do it from the conditional or the converse, because the whole idea is they're reversible, so you may say it either way, okay? So our biconditional would be the sum of 2 angles is 180. I'm just taking out the measures, but it's the same thing. The sum of two angles is 180, and here's where your IFF goes in. If and only if the two angles are supplementary. Okay, now that would be the same as if I said the two angles are supplementary if and only if their sum is 180. So I don't care which one you use to write. If you want to write it from this one, take out the if, take out the then, and put in the if and only if for that, you could do that, okay? You may use either statement, but they both have to be true to start with. If one of them is false, you just say, not possible. I cannot write a biconditional because it doesn't work both ways.
What is the IFF again?
If and only if.
Oh,
Okay, so here's the idea. This is it in like the shorthand form. If your if P then Q is true, and your if Q then P, so your conditional is true, and your converse is true, then you can write the biconditional, if and only if.
I just turned around.
Okay? Does that make sense? Okay, so let's flip that around. Forrest, stop talking. The other way you'll see it is just the reverse of that. Now they're going to give you the IFF statement, and you have to write the conditional and the converse. What's a conditional? An if.
And only if.
No, that's a biconditional. A conditional is an if-then statement, right? So we're going to write from this an if-then statement. So write the conditional and write its converse. So if it says array is an angle bisector, if and only if it divides an angle into two congruent angles, can you make that an if-then statement for me? If what?
If it divides an angle into two congruent angles, then it is a great. Never mind. It's okay.
You're not wrong. You're just giving me the converse right now,
Take that back.
which technically you could argue could be the conditional too. If what? So take this out, put in the if then, right? It's just the reverse of what we just did. So now we're going to say if array is an angle bisector, then it divides an angle into two congruent angles. All right, so you're going to take out the IFF and put in the if then. So really you're just doing the opposite in these two types of problems. Either you're putting in an if then or you're putting in an IFF in place of the if then. Okay? So tell me what the converse of this is.
If it divides an angle into two congruent angles, then it is a bisector.
Then the array is an angle bisector. Yeah, so let's say if array, just so we know what it is. If array divides an angle into two congruent angles, then it is an angle bisector. Okay? So notice the difference. These are really like just exact opposites of each other. This one, they gave you the if-then, right? The if-then statement. You had to find the converse to see if you could write the biconditional. When can you write a biconditional?
If and only if.
It is if and only if. What has to be true?
Oh.
Both of them, the conditional and the converse. Okay, so let's say, you don't have to write this down, but I just want to give you one more example of each just to make sure. Let's say I say if an angle is a right angle, then its measure is 90. Okay, don't even write it down. Just talk to me. If that's my conditional statement, first of all, is it true?
Yes.
That is true. If an angle is a right angle, it's going to be a 90-degree angle, okay? What's the converse of that?
If it measures, then what is a right angle?
If its measure is 90, then the angle is a right angle, right? So we just swapped them. Is that true?
Yes.
Yes, that is true. So when they are both true, what do you do? How do you write a biconditional? What do you take out and what do you put in?
Take out if and then you add IFF in between the two.
Yeah, where? IFF replaces what word?
Or then.
The then, right. So you're going to take out your if, and you can do it on either one. You can do it here or you can do it here. You can do it here or you can do it here. I usually go back to the original, but you don't have to. It's not wrong if you use the converse, okay? So I'm going to say for my biconditional, an angle is a right angle, then what? If and only if its measure is 90. Does that make sense?
Yes.
So when is the only time you can write a biconditional?
Converse and conditional are
If
true.
both are true. Okay? Okay, now let's say I give you an angle is acute if and only if its measure
You got tricked. 49%.
Okay, so now this is my statement. An angle is acute. Don't write it down. Just speak it or talk to me about it. An angle is acute if and only if its measure is between 0 and 90. How do you turn that into a conditional and its converse?
Well, Bill,
What's the conditional?
I like
I think
chocolate.
it's my favorite part. That's why I like
What's the conditional?
Oh, if it's between. Actually, because I already know the answer.
If the angle is acute, then its measurement is between 0 and 90.
That'd be your conditional, right? So you take out, this is just the reverse. Take out this, put in an if and a then.
And then for converse, if its measurement is between 0 and 90, then that angle is acute.
Correct. Does that make sense? Yes? We feel good about that?
Does it make sense, guys?
Okay. That's what you're doing today.